Howdy and welcome to space.com. UIE's Hope Mars mission discovers patchy new aurora variety over red planet. The new results come from a partnership with NASA's MAVEN mission. The Emirates Mars mission has discovered patchy proton auroras above Mars, suggesting unexpectedly chaotic conditions where the solar wind interacts with the red planet's upper atmosphere. House of Dragon. Having arrived in orbit around Mars on February 9th, 2021, the United Arab Emirates HOPE spacecraft has been monitoring the red planet with, among other tools, its Emirates Mars Ultraviolet Spectrometer instrument. The mission team had hoped to use the instrument to see variability in the composition of the upper atmosphere of Mars, in particular the prevalence of oxygen and carbon monoxide, as well as to spot hydrogen and oxygen escaping into space as the red planet's water slowly leaks away. So does Earth's. To support that work, EMU's designated to detect ultraviolet emission from protons, hydrogen nuclei in Mars' atmosphere that have been excited by the solar wind, the stream of charged particles that constantly flows off the sun. To scientists' surprise, rather than seeing a uniform glow at these ultraviolet wavelengths, EMU's showed that the emission can often become patchy. What we are seeing is essentially a map of where the solar wind is raining down onto the planet. Mike Caffin, who is a HOPE team member from the University of Colorado Boulder and lead author of a new paper detailing the findings, said in an emailed statement. Yeah, we can watch this later. Mars does not have its own global magnetic field like Earth to shield against the solar wind. But its thin atmosphere still acts as a barrier that can deflect the interplanetary magnetic field carried on the solar wind around the planet. So how is the atmosphere there if there is no magnetic field? There is a magnetic field, otherwise there wouldn't be any atmosphere or whatsoever. It has to be. Mars is connected to the sun by the interplanetary magnetic field lines and all these kind of things. But anyway, this deflection causes the solar wind to slow and pile up as it drapes over Mars, creating a concentration of charged particles called plasma that can interact with residual magnetic field lines that remain in regions of Mars' crust. Remember that. Creating a concentration of charged particles called plasma that can interact with the residual magnetic field lines that remain in regions of Mars' crust. Scientists already knew that this plasma environment and its connection to the magnetic fields emanating from the surface of Mars could influence how, where, and when hydrogen and oxygen leak into space. It now seems that it can also influence the location and intensity of proton auroras when the magnetic field carried on the solar wind aligns with magnetic field lines coming from Mars' surface, along with which protons are traveling. Normal proton aurora formation. Patchy aurora formation. Somehow this doesn't look really. There is missing north and south poles and such. But anyway, the findings came in conjunction with NASA's MAVEN Mars Atmosphere and Volatile Evolution mission. which is also in orbit around the red planet and is able to observe local plasma conditions in the upper atmosphere. Together, the two missions have provided a comprehensive view of what is occurring. Access to MAVEN data has been essential for placing these new observations into a wider context, Hesa Al-Matrushi, Hope's lead scientist, said in a statement. Together, we are pushing the boundaries for our existing knowledge not only of Mars, but of planetary interactions with the solar wind. Earth is a planet. Mars proton auroras were initially detected in 2018 by MAVEN, but the NASA missions only saw them as a uniform glow on the day side of the planet. The high spatial resolution of EMUS was able to detect patchiness that coincides with turbulent space weather. Full disk patchy proton aurora. Localized patchy proton aurora. For example, in observations gathered on August 11, 2021, a little bit more than a year ago, the aurora is so widespread and so disorganized that the plasma environment around Mars must have been truly disturbed, Chaffin said. The differing extent and location of the patchy proton auroras could indicate different conditions in the plasma environment around Mars, resulting from variations in the solar wind and even the Martian season. Although no new results have been released yet, summer 2022 coincided with summer in the southern hemisphere of Mars and was expected to produce large number of proton auroras. Our discovery of these patchy proton aurora adds a new kind of event to the long list of those currently studied by EMM and challenges our existing views of how the proton aurora on Mars dayside are formed, Al-Matrushi said. So now let's go back up again. Maybe still a bit more. Here it is. This deflection causes the solar wind to slow and pile up as it drapes over Mars, creating a concentration of charged particles called plasma that can interact with residual magnetic field lines. My left thumb is a little bit shaky. That remain in Mars, in regions of Mars's crust. That's much easier to draw with the right thumb than with the left. But anyway, that can interact with residual magnetic field lines that remain in regions of Mars's crust. You have seen this map. The surface conductivity anomaly in Scandinavia. Source European Planet Observation System, EPOS. So, this is sea pinch. I assume the red are positive and those are negative. But since the whole page, and not the whole page, but the whole article and the picture has been taken down from the internet, it's impossible to read about it. Yeah, it got taken down after I took contact with them. Might be just a coincidence, but it seems so. It is like this. They never answered anything to me. But it's not there anymore, which is a pity. But anyway, here is Finland, Sweden, Norway, Russia. Why I show you that? Because that's an imprint in Earth's crust. A surface conductivity anomaly in Earth's crust. Down here we have the Kursk magnetic anomaly. And that's a Wikipedia picture. And that's the Kursk magnetic anomaly. There's another anomaly here down in Africa. But the Kursk magnetic anomaly is in its own way very special, especially when it's linked to the surface conductivity anomaly. And if you watch this border, this is always visible, not always, but almost always visible, also on windy on the weather maps. That's some little more drawing that I did about this surface conductivity anomaly. I tried to fit this as accurate as possible, since I cannot make any overlays onto the map of Google Earth. And I drew the lines and arrows from high and low pressure systems, in which direction they are supposed to turn or spin according to their polarity. So high pressure system, low pressure system. And that's a picture of Earth's magnetosphere and these kind of things. And here we have the polar cusp. Incoming solar wind particles, which goes to the poles. Which is obviously the problem on Mars, because they are so patchy, there's not really... They couldn't find yet, or at least in the article, there isn't any north or south pole on the Mars, because the auroras are where they are. And obviously they are very closely related to the things which are on the surface of Mars. So, the polar cusp is up here, which is quite a distance away from Earth. That's the cusp reconnection, which is basically the area up there in close up. And if you take the surface conductivity anomaly and the polar cusp reconnection side by side, you probably notice that there are similarities between those. So, if you think about that, the polar cusps are up here, and we have an imprint of approximately a similar thing here on Earth. I somehow think it's possible that it came down and made an imprint, because the stream or whatever, it was wobbling, as does my left thumb when I try to draw something. And it might have smashed into Earth's surface. And I have been talking about this very extensively, about these things having large influences in the weather patterns down here on Earth. And now it's even in the news. They fear that a stable high pressure system in the winter with very cold air could be the thing which might shut electricity providing here down in Finland. They have to rationate it. 2 hours without electricity, shops are closed, and all these kind of things. The reason why or how I found this map, which is not in the internet available anymore, was that I noticed a high pressure system here. A very stable high pressure system. It was just here spinning around, like going back and forth. Especially in the summer or winter. Not so much in fall or spring. But after it settled into this kind of season, which is rather stable, let's say summer or spring, summer or winter, because fall and spring are these kind of seasons where so many things happen. And I found this through Windy, basically, watching the weather. And since Earth's magnetic field is weakening and so many other things are going down, I think these kind of imprints on Earth's mantle will have more and more significance regards to the weather. The actual weather, wind, rain, hail, snow, drought and flood. Probably, or maybe, there will be patchy auroras seen on Earth as well in not so distant future. Maybe those patchy auroras on Mars are indicators of the cosmic current sheet hitting our solar system. Changes on other planets are happening. Also on Earth, obviously. You have probably felt some of this. Drought, heat, flooding, hail, or whatever. Extreme weather. The last 400 years were so gentle to humans or mankind in general in terms of weather. It won't continue like this. The gentleness is over. Just watch. Watch outside. Watch the heavens. Look at the clouds. Learn about clouds. Remember that clouds are plasma. Weather is driven entirely electrically. You can imagine this would be a pillar of negatively charged, let's say a low pressure system. You are somewhere here. And there is another pillar, which is positively charged, which is a high pressure system. And if you would watch it from above, this would spin like this, and this would spin like this way. I can't see what I draw. This way. So hence, in the middle it goes in this direction. And when you are here in the middle of those, you are always between some weather systems. So it's spinning. Oh no, my very nice drawing. I just try to explain to you that all the winds you experience on Earth are ionic in nature. Two magnets, and they will either repel or attract each other. And there's electricity flowing around them according to their polarity. There will be electromagnetic currents. They create the winds, ionic winds. And if there is enough energy in the air, it will create clouds, so the streams get visible. And I have also been talking about switch of the polarities, or how to put it, from the surface conductivity anomaly. It will flip around every now and then. Now it seems to have switched. Since the stream, which some time ago still went up here in the middle, it goes now on the other side, southwards. And here everything comes together. From up here, from here, and this is keeping its own position. And this might explain why we have the quakes here in the middle. And there is still more energy pushing in. This seems to hold its place. So the energy which accumulates in a way here between those weather system currencies might induce energy into the ground and we experience earthquakes and such. But anyway, I leave it here. Patchy auroras on Mars, maybe soon on Earth too. Let's see. Thanks.